Welcome to today's explainer. Okay, so today we're going to completely shift our mindset away from those traditional grid-based spatial layouts. Instead, we're diving deep into dynamic, nonlinear edge systems that maximize yield and really boost ecological resilience. If you've ever stared at a standard rectangular garden bed and thought, there's got to be a more efficient, mathematically optimized way to grow things, well, you are in exactly the right place. Today is all about the step-by-step design and spatial layout of highly productive edge systems.
Here is our quick roadmap for today. We'll start with beyond the straight line, then dive into the edge effect explained. After that, we'll look at designing crenellated pond edges, keyhole gardens and mandalas, the 3D herb spiral, and we'll wrap it all up with the philosophy of edge. All right, part 1, beyond the straight line.
Now, this brilliantly illustrates our core conflict here. A straight fence is, well, it's merely a harsh border, right? But a sinuous, wavy boundary actually functions as a dense, planted edge that does real ecological work. Think about it for a second. Conventional farming relies on straight lines mostly for the sake of mechanical machinery. But nature absolutely doesn't work in straight lines. A simple, straight fence separating a pasture from a forest is just a boundary. If you can walk right through it without touching a single leaf, it's not a functional edge. But if we curve that line, if we make it sinuous and wavy, we instantly increase its perimeter. We can then plant that transition zone with a really dense, diverse mix of species, turning it into a living, working part of the landscape rather than just a boring divider.
Moving right along to part 2, the edge effect explained. So, the absolute most crucial concept we have to grasp here is the ecotone. This is that overlap area, and it basically acts as a giant energy trap where different species interact and thrive. Let's say you have an ecosystem with 3 species, and it meets another ecosystem with a different 3 species. The ecotone where they overlap doesn't just have 6 species. No way! That unique combination creates conditions that support entirely new, specialized species you won't find in either parent environment. We see this all over the place in nature. Think of mangrove forests at the land-sea interface, or coral reefs right at the ocean shallows boundary. These are some of the most hyper-productive and biologically diverse ecologies on the planet. And this incredible productivity is driven by 3 primary mechanisms. First up, resource access. Organisms hanging out in the ecotone can pull nutrients and resources from both adjoining environments in one concentrated spot. Pretty smart, right? Second is microclimate complexity. The physical boundaries create these rapid gradients in moisture, temperature, and light, which generates an incredibly dense array of microniches. And third, we have trophic cascade amplification. Basically, the increased light and resources at an edge stimulates this explosive plant growth. That brings in more herbivorous insects, which then attracts a super high concentration of birds, pollinators, and predators. It's quite literally a compounding engine of life.
Which brings us to part 3, designing crenellated pond edges.
Now that we have the theory down, let's apply this to a macro-level intervention, water bodies. By looking at natural systems, like a winding river, or honestly, even the human intestine, we learn that lobular or crenellated shapes maximize surface area for absorption and interaction. Crenellated just means wavy or having small, square indentations. A river doesn't cut a perfectly straight channel, it meanders, and that wandering path increases water penetration into the land, creating a vastly larger riparian ecosystem. As designers, we can intentionally engineer this pattern to radically increase our growing capacity. This is exactly what we see in those highly productive ancient Shinampis-style systems that brilliantly interlock agriculture with aquaculture.
Now, this is where the sheer spatial math gets really, really fun. Let's say you're building a pond with an 11.3 meter diameter. That gives you exactly 100 square meters of water surface, right? If you dig that pond as a perfect circle, you get a fixed amount of shoreline to plant your water-loving crops like blueberries or watercress. But if you take that exact same 100 square meter water volume and crenellate the edge, giving it deep, wavy lobes, you can literally double the effective circumference. You double your highly productive edge interface and your plantable area, all without taking up a single extra drop of water volume. It's amazing.
All right, stepping down from the macro level, let's hit part 4, keyhole gardens and mandalas.
Let's look at 2-dimensional earthworks. The keyhole pattern follows this brilliant functional progression. You see, the fundamental rule of healthy soil is that you should never ever step on it. Soil compaction destroys the structure and totally ruins plant growth. Traditional gardens use straight parallel paths, which means up to 50% of your garden area is just compacted dirt reserved for walking. What a waste, right?
The keyhole bed solves this completely. It's designed around the maximum reach of the human arm. By creating a central node with a small path leading in, shaped exactly like a keyhole, the gardener can reach every single plant without ever stepping on the growing area. It increases the planting edge, allows for super dense clustering, and keeps that soil pristine. Let's see how this builds into 3 dimensions with part 5, the 3D herb spiral. Let's look at how powerful this is in practice. Picture a flat circular garden bed with a diameter of 1.6 meters. Basic geometry tells us that gives you about 2 square meters of planting space. But what if we bring in some soil, build a central mound to a height of just half a meter, and then wrap a stone retaining wall around it in a spiral? We just transformed a flat circle into a cone. That planting surface area jumps to 2.4 square meters. That is a solid 20% physical gain in productive surface area, sitting on the exact same geographical footprint. But the real magic of the herb spiral isn't just about the surface area. It's about optimizing microclimates. If you kind of mentally walk around this 3D structure, you can easily map out how distinct environments allow entirely different ecosystems to thrive within inches of each other. The sun-facing side acts as a thermal mass. Those stones absorb heat and radiate it back, which is absolutely perfect for hot, dry Mediterranean herbs like rosemary and thyme. On the flip side, the shade-facing aspect is cool and damp, making it an ideal home for parsley and mint. Up at the very top, the apical zone, you get rapid gravity drainage, keeping the soil nice and dry for sensitive roots. Meanwhile, the basal zone, right at the bottom, collects all that runoff, creating a wet sink that watercress just loves. It really is a masterpiece of integrated design. Finally, let's tie it all together in part 6, the philosophy of edge. This brilliantly illustrates our ultimate goal for this explainer. Designing efficiently means letting nature's complex geometries do the heavy lifting for us. Whether we're looking at a microscopic cellular level or massive macro-scale agroforestry, the edge is where the action happens. It's all about designing landscapes that behave like living systems, using shape, form, and topography to passively capture energy, water, and life. We are intentionally shifting away from an old paradigm of straight lines and isolated parts, moving toward a world of integrated, overlapping ecosystems. So as you step out into your own landscapes today, I want you to look really closely at your borders. Where the pavement meets the grass or where fences divide fields, how will you reshape those straight lines to multiply their potential and let nature thrive? The opportunity for incredible diversity and yield is literally hiding right there in the margins. Thanks for joining me for this explainer, and I absolutely cannot wait to see what you create.